I'm going to start with the slide who I am. I'm actually working for Deutsche Telekom PanNet. Most of you probably already heard of Deutsche Telekom, but most of you probably didn't hear about PanNet. So PanNet is a spin-off company of Deutsche Telekom that is managing or working on OpenStack clouds for Deutsche Telekom companies, for other companies. It started as a project inside Deutsche Telekom, and last year it was split into a separate company. Previously, I have been working for a San Francisco-based cloud startup, but actually I needed some money, so I changed the job to some bigger company that pays much better than San Francisco startups. What we do in PanNet, I work for the security team, and we are focusing on continuously delivering security infrastructure components into OpenStack clouds. So I'm not going to talk about OpenStack itself. I'm going to talk to how to build infrastructures on top of OpenStack. In the beginning, we get username, password, authorization URL for OpenStack API, and at the end, we are expected to deliver security services to customers that are basically inside our company, not outside. So we are building the black box where you throw your OpenStack URL, OpenStack username, OpenStack password, and at the end you get the all working infrastructure without any touch. So we actually are programming the infrastructure. This black box contains something that creates machines, that installs and configures the services, and does the setup. I will talk about it in a second. What is the advantage of this approach to what we do actually is a system administration? In the past, for a task like this, you would hire an LDAP administrator, web server administrator, storage administrator, and so on and so on and so on. With OpenStack, we got all of these things as a service, and we got all those administrators as components inside our programming in the infrastructure. We never touch any machines directly if we don't develop anything. If we do life cycle management from development to production, we don't SSH to our machines. I don't say at all, but we try to not SSH at all. A number of resources that we manage doesn't matter at all. It doesn't matter if I manage 5 servers or 5,000 servers. With the tools we use, you probably are aware of this, so I don't need to talk about this. From idea to production, everything is logged. So when someone, our management or boss comes with any idea, it's just typed into some system, then it's discussed, then it's translated into code, then it's tested and managed into production. I want to highlight, I'm not talking about the software development. We are developing and we are orchestrating tools to do the job. We are not writing any software itself. A separate chapter would be project management is in code. I can talk about this after the lecture. It's a very funny story from inside our company. We focus on automation. This means we at the end of the day, no one does anything by hand. Everything is automated inside some software. This approach is very nice in a thing of it's easy to develop from a simple part. How to explain this? Our infrastructure has plenty of different components from different vendors like Apache, Nginx, AJ Proxy, different LDAPs and databases and so on. And when we were at the beginning, we just started with one component. First of all, we were creating the basic automated process, and then we added some more components, and we were adding something that was not working to some part that was already working, and then improve the non-working part to a working part. And for all this process, we need plenty of tools to do some part of the jobs. We always choose tools that fit some part of the job we need to get done, and Terraform is one of those tools. So, to explain some vocabulary, provisioning for the topic for this talk is a process of creation of SSHable infrastructure. So at the beginning you have the login and the password, and at the end you get an IP address when you can SSH. It's a little bit contradictory to what I said before, but I don't SSH, machines do SSH for me. And deployment is the part when you apply configuration to any running operating system. So you got Ubuntu image that is plain without any configuration. You apply configuration, you install daemons, you apply hardening, you set up centralized logging, you set up proxy, and so on and so on. Then you install daemons and customize the daemons configuration files. And the third part is setup. This is might be confused with the deployment, but setup is any step that doesn't apply to a single component, but that applies. For example, you create users, you create roles inside identity provider, you define all those interactions between those things you create inside. To simplify it, it's when you fill the database. During the deployment, you create some database structure, and at the end you insert something into database, you upload files, you customize your IDP with your company logo and so on. So this has nothing to do with deployment. At the beginning, what were our provisioning options? Before doing any creation of resources, when I joined the company, they already had the one component that we were deploying. It was called IAM, Identity and Access Management. They tested and integrated all those components together. They tested it works and it will provide all the service. And they wanted to automate the provisioning and deployment and to supply this or offer this as a product to other teams in our company. So now if you come to our team and say we want to deploy IAM solution somewhere, we just ask you for your credentials, or we give you this, we give you a configuration file for the IAM. You just click play. That basically means you have to have all the tools and it will deploy it for you. For deploying software, we were already using Ansible. We had some roles that we were improving, and there is a OS_server module in Ansible. It's a module for managing your OpenStack components using Ansible. This means you supply some parameters, run the playbook, it checks the actual status of the infrastructure against OpenStack API, then evaluates whether it needs to create something or change something or destroy something. And our problem was that the script was pretty huge, and when we played this playbook, it took plenty of time to do the job because it was how to say, very, very, very slow. It took like 20 minutes to check whether for the basic component, we have 48 virtual machines. For 48 virtual machines, it took 20 minutes for existing infrastructure just to verify it exists and we don't need to change anything. So this was unfeasible for us because imagine if you have a system like this with 48 different machines with around 8 or 9 components. Whenever you need to do any change, you don't go to your server, edit some configuration file, save it, restart the service. What you do is you commit your change into GitLab. There is some review process. Someone checks whether this change is relevant and it doesn't contain any bugs. And then all our components are run and are checking whether infrastructure is corresponding to the definition. This was not possible with Ansible for provisioning. Because, well, I'm a little bit lost in the presentation, sorry. Ansible didn't store any cache of the current state against the Nova API. This is why the process was so long. You probably all know Heat. Heat was a component that we were actually not able to use because it expects that there is a server component inside OpenStack. When we were beginning the development, there was no heat orchestration engine, or how you call it, inside our OpenStack. So we were not able to contact it. And our administrator gave us direct access to OpenStack API. So we were very happy that we at least got some access. And when I joined the company, they told me you will have to use the salt stack. I opened some files and I say, OMG, I need to leave this company right now. I didn't like it at all. At the beginning, we also had, of course, what's the name of the dashboard? Horizon, where we clicked some of the machines we were developing on. But you know, if you have 48 machines to deploy, you say, okay, I can do this once, but I can never do any change in 48 machines. So, to be honest, first of all, I used OpenStack CLI that created those machines for me because it was simplest solution. I didn't want to waste time. But who of you are using directly OpenStack CLI, you know that the syntax is changing so often that if you upgrade your OpenStack CLI from version 1 to version 1.1, some of your parameters are deprecated, some of parameters are added, some of are removed. This is not what you want to use in long term. There was an option for Juju, but we didn't consider this. I know nothing about Juju, and I just included it for completeness. And finally, we got to Terraform. That's what this talk is about. So how does our infrastructure look like in OpenStack? First of all, basic component is the instance that has one or more ports. Port is a part of some security group or security groups, and every security group contains some security group rules. Every port is related to some network, and network is related to some subnet, and also we use something that we call VIPs, virtual IPs, that we share between interfaces on load balancers for some of our services. Actually, this resource in OpenStack we just created, pick the value from it, we just reserve an IP address for us because the IP addresses are managed by OpenStack folks. And we don't use this resource anymore, we just then use this value, and using Ansible we put it into configuration file of keepaliveD, that is a daemon that manages the failover of IP addresses. And we also use the server group. What we do with Terraform, it's in the next slide. This is an introduction of what is Terraform. It's they call it ultimate infrastructure as a code tool under, this is what I added, under development. The current version is 0.9.6, and even it looks like it's close to 1.0, it's not even there, and I'm pretty sure that they will have 0.10, 0.11 and so on. I want to warn you, everyone, that it's really not stable, but I will tell you how to go around this. And it's under very heavy development. It's developed on GitHub. Everyone can contribute, and it's developed by a company that is called HashiCorp. If you never heard of HashiCorp, I'm sure you heard of Vagrant. Vagrant is a tool that was developed by 20-something-year-old guy called Hashimoto, and he created Vagrant as his work at school, and it was so quickly adopted by all the community around the world, so he founded HashiCorp, and the same approach he used with Vagrant. His company develops plenty of different tools for managing different cloud and software things, and Terraform is a tool that is used for provisioning, for creating, for management of infrastructure that you declare as a code. Very big advantage of this is you just download it from internet, unzip, chmod, and run, and you don't need to install any dependencies. It's developed in Golang, so they offer you with a binary distribution that has no dependencies. So you can start in a second. How Terraform is used? First of all, you declaratively describe or code your infrastructure components, or they call it resources. So you write down a definition. I will show you some examples in a second. When your infrastructure is already declared, you call the binary, which then communicates with your cloud provider APIs. In our case, it's Nova API, and checks whether the definition of the infrastructure is corresponding the actual objects inside your OpenStack. Most important things is, and compared to Ansible, the winning one, Terraform keeps its own cache of your infrastructure. So if you create your infrastructure definition and your resources already exist in OpenStack, you already deployed something and you want to use it with Terraform, by default you have a 0 or clear or no state file for your infrastructure. So if you call Terraform plan, it asks the API whether those 0 components exist, and then it creates all the infrastructure even if it exists. So if you want to use Terraform for infrastructure coding, you have to start from scratch, or I will tell at the end of the speech how to import your existing infrastructure into Terraform. The what they sell as a most important feature, they support multiple clouds. My note is those that are implemented and not buggy, because it still contains a lot of bugs, and I will show you some bugs later for OpenStack. And the very good advantage is you can start from very scratch. You can start with only one VM, manage your one VM, and after you see you can work with Terraform, you can add some more and some more and some more components. You can import them from your existing infrastructure, and it's at the end it's very easy to work with it. This is what I call my first picture, what I call Terraform life cycle. First of all, you write your infrastructure definition. It's written in they call it HashiCorp configuration language. It's basically an extended JSON. So it's fully compatible with JSON. If you have a JSON, it's always validated. If it's valid JSON, it's valid HCL with some additions like extrapolations, commands, and so on, not important for this talk. And you can, of course, version, and you are expected to version your infrastructure inside of some SVN. We use Git. This is a logo of GitLab, so we manage it in GitLab. After your infrastructure definition is written, you call Terraform plan. That is something that communicates with the API and checks the actual state file and tells you what are the steps necessary for making your infrastructure up to date. Of course, if it's up to date, it says 0 changes. If your state file is empty, it will list all the steps necessary to do, like create this resource, change this resource, delete this resource, and so on and so on. But when you call plan, it actually never touches anything existing inside OpenStack. After you are satisfied with the plan, you call Terraform apply. That actually does the job that was planned and saves it to the state file. Now I want to stop for a second. We use Terraform in a continuous delivery environment. So if you can imagine what continuous delivery environment is, when you commit something into GitLab, all the steps of continuous delivery pipeline are run. So if you run Terraform plan, and I told you, you need to check the plan, what is it going to do? It's a showstopper for continuous delivery, because you need to stop the process, examine the Terraform plan yourself, and if you are happy with the plan, then you, fortunately in GitLab there is an option to pause the pipeline after certain steps. So this is what we did when we were developing our infrastructure and didn't want to Terraform to destroy it. The good thing is, if Terraform destroys anything you don't expect, it will create it back, because it should match your infrastructure definition. But If you are using Terraform as we do, that means we create vanilla Ubuntu virtual machines. Then, if in previous steps you applied some configuration and some setup to your VMs, then Terraform destroys some of your components and recreates it again. The component is empty and you need to redeploy it. So in our CI/CD process, we of course have to focus on when you throw an empty machine into Ansible playbook, it has to always apply all the configuration, and this would be for a separate 1 or 2 or 3 hour lecture. Maybe most interesting than even this Terraform thing.
So, sorry, Martin, you are using Terraform in order to deploy the virtual machines, and you're using Ansible to apply the configuration to those?
Yes.
Well, can I have a question? So
yeah.
Is my assumption correct that the state file is caching the resource names instead of the UIDs for them? So I've seen recent blogs that if we renamed network IDs or network names in OpenStack, it was taken by Terraform that, hey, there is no such network there, so I should redeploy the entire.
Well, that's a tricky question. If you have an existing infrastructure that is deployed by Terraform, then you change the name outside of Terraform. Then you can Terraform plan or apply. It will tell you this resource, because it's the resource itself is identified by UUID. So Terraform will tell you this resource has to be renamed back to the original name, and we'll do it for you if you are permitted to do so. But the funny story about our environment, we don't with my OpenStack credentials, I don't have permissions to do all operations I need in OpenStack, because our administrator was unable to grant me those permissions. To be more specific, it's on an OpenStack port there is an attribute called allowed IPs, where you list IP addresses that are allowed to be bound to this interface. And what I needed to do was create all those infrastructure and then call the guy to change this value for me and then manually import it to Terraform state file. At the end, I will tell you never use or be very, how to say, I don't want to tell you never use Terraform on non-automatic infrastructures, because our cloud is not fully automated for this reason. But beware of non-automated infrastructure. Terraform, what we experience with is, from time to time, we deleted some, Terraform ordered Nova API to remove some resources that we didn't have permissions to remove. OpenStack API said, okay, I'm going to delete this resource, returned okay to Terraform binary. Terraform removed it from the state file, but the resource actually existed in OpenStack because I was not permitted to delete it. But Nova API returned okay, returned no error.
Okay, so the moral of the story, if you want to use Terraform with OpenStack, the best to have admin access.
Sorry?
The best to have an administrator access or role.
Well, you need to have the access to create and modify all the resources you want to create or modify. That doesn't necessarily mean administrator. I have never been administrator of any OpenStack component, so I don't know. This is a very stupid slide, but I highlighted some of most important resources they offer. Terraform has very active development, and those components, if you see some of those you use. When I created these slides 2 days ago, I was really surprised that there are many more resources than I expected. So they added some in recent versions. But to be honest, whatever I ever needed with Terraform, I found with OpenStack, I found it already in Terraform. So what's the basic, the simplest definition of a resource in Terraform? You write resource, then this is the type of the resource that's defined by Terraform tool. OpenStack networking subgroup v2. Then it's a name that is unique to this resource. Then you say what is the name and what is the description, IDM backend servers. What this look like? It's another side. Then I will show you how this looks in the state file. You can also use something that's called variables. You probably know variables. You declare a variable that's, in this example, it's called domain. Description is the domain name, and then you declare the value of this domain, and of course you can later use it in your definitions. So this is a definition of example definition declaration of resource of compute instance resource that is using some advanced features of Terraform. So I will try to explain everything to you. Count is an attribute that says how many of those resources have to be created by Terraform. And actually this refers to a variable. It's a map of key value pairs. The key is, in this case, is IDM, and the value actually would be 2, or I don't use it anywhere, so maybe 10 or 20 or whatever you need. And it will just create 20 different resources that will be called OpenStack compute instance .v2, .idm, .0, .1, .2, and so on, that you can later refer to in different resources. Then you use the name. It's using what they call extrapolation. So when you refer to something else that is not static, they call it extrapolation. For example, this is referring to the domain I showed on previous slide, and this is referring to the count number of these machines. There is +1 because Terraform numbers it's from 0 as in regular computing environment, and there is also some extra 0 added in front of. Of course, this will not work for more than 9 instances that we don't yet use. Image ID is a reference to image ID that is actually a variable, but image is something we manage outside of Terraform. There would be ways how to manage images with Terraform and another tool from HashiCorp that is called Packer, but it's out of scope of this lecture. So basically this is just a variable containing the number of the image stored inside the OpenStack. Flavor name, simple. Key pair is a reference to the key pair, and availability zone is just a hard-coded parameter. Then you can use metadata. That is very important for our Ansible deployments. Anyone not aware what metadata in OpenStack is? No response. So we just add some tags that we later use for creation of Ansible inventory files. And then we group our VMs into some logical groups that we later call Ansible playbooks on. So what this basically is used for, before we run Ansible, we download the infrastructure from existing OpenStack. We don't use Terraform for outputting any inventory file. We always use the Nova API to ask what instances are existing. We ask it for metadata, we generate the inventory file and run the playbooks. And then there is a definition of network. When you create a VM when you declare a VM in Terraform without network, it will create a VM with no network interface. But if you create a network and you don't refer to a port, but you refer to name, you just, or a subnet, then you tell which network should Terraform create, or OpenStack Nova API should create the interface in. But this has some problem. When you create such instance, you can imagine that VM and ports are two different resources in OpenStack. And if you create VM without this declaration, it will create the port as well, but the port will be managed outside of Terraform. It will be bound inside the OpenStack API, so if you remove an instance later, it will remove the port as well, but you are unable to manage port itself, you are unable to refer to any attributes of this port inside your infrastructure definition. So this is what we do, and this is the most advanced extrapolation I use. Somewhere else you define a port with a declaration very similar to this, and I create a bunch of OpenStack port resources, and then using this extrapolation, I refer that for instance number 0, use resource OpenStack networking port named port backend with the index 0. So if I have 20 different OpenStack ports and 20 different OpenStack instances, I can, using this extrapolation, I can refer between them. And then this was very important because in our cloud we didn't have a DNS as a service, so when we destroyed an instance and created it again, the IP address was changed. So we had to go to DNS, edit DNS record, and wait until TTL expired, what at the end was only 60 seconds, but you always had to deal with DNS editing. So we separated the port outside of the resource of the VM definition, and then when we destroyed the VM, Terraform evaluated it doesn't need to destroy the port itself, so it just decoupled the port from the instance, destroyed the VM, recreated the VM, and attached the port back to the instance. That saved us from the DNS editing hell. This is how security group rules like. You already have seen a definition of security group, and security group rules is just basically what you know from Horizon or from other OpenStack tools. Direction, ether type, protocol, port range minimum, port range maximum, remote IP prefix. And there are two different options how to refer to to the opposite side for the security group. Here it's called remote IP prefix. This means it allows some IP address to communicate with your security group. Or you can say the remote security group ID, and you refer to another security group with an extrapolation that would be very similar to this one. You see that this security group rule refers to this existing security group, and it just fills in the ID that you know you ID from OpenStack. Here I will stop for a second. As I told you, Terraform is not very mature, so we hit a bug in Terraform, or no, it's not a bug. It's a non-implemented feature that caused us some hurt. When you have a definition like this and you make some typo, or you want just to rename the existing security group in OpenStack, it was not implemented in Terraform. So what Terraform is the best effort tool. So it still wanted me to satisfy me with at the end of the run with an existing security group with the correct name. So it wanted to destroy this security group, but to destroy this security group, it had to destroy all the rules. So it destroyed all 20 rules I had in the security group, then destroyed the security group, then recreated the security group, and created all those rules again. That would be the simple part, because if you destroy the rules and you create them again, the only thing what happens is, until you recreate them, your service is not available for your clients. You know, because when you do it in security group, the rules are applied, and for the 10 seconds you are recreating the infrastructure, your security group, your communication is not working. That would be the less painting part, but later on we needed to when you change the security group, it's bound to an interface, and it was unable to deassociate the security group from the port, so it wanted to destroy the port as well. And if we wanted to destroy the port, it wanted to destroy the instance itself. Now it's filled as a bug in GitHub. What's good about Terraform, when you create a bug report in GitHub, they are -8 hours, so if you file a bug in the evening at your work, until you wake up in the morning, the bug is most probably fixed, if it's a small bug. This happens to 5 or 6 bugs I reported on, and the dependency bug is still there, and they still didn't fix it because it's somewhere in the Terraform core. At the end, at the best practice, I will mention this again. You already heard about the state file. State file is by default set to a local file on your file system on the machine where you run Terraform, which is too bad if you want to share it with your colleagues or if you want to run it in some distributed environment. Fortunately, since version 0.8 something, they support different storage backends. And fortunately, you can, in OpenStack environment, you can use Swift, but there are dragons. So Terraform doesn't support locking for Swift environment. So if you solve the problem of sharing your Terraform state file with your colleagues using Swift and granting access to all your colleagues to the Swift container that is relevant to your infrastructure, you still have to care about how to lock the file if both colleagues run the Terraform in the same time. I actually never did it, but both of them might write to the same file, and at the end you will have an inconsistent state. Other thing about the state file is you need to backup it very well, because if you lose it, then Terraform thinks your infrastructure doesn't exist anymore. And there is an option to recreate the file, but it's very painful and it's still not implemented in all resources for OpenStack. And if you are going to use Terraform, you should be able to edit your state file if you need it, because state file is just a simple JSON. And for example, now, 3 days ago, they released version 0. The last stable version 0.96. And before we were using 9.1 / some commit in GitHub, we compiled manually. And they made some incompatible change into Terraform to maintain some compatibility with something I don't know. I had to edit my state file manually to make Terraform work with the new version. But the state file is not so complicated. It's just a JSON, a plain JSON. It's not HCL, I think. So this is how Terraform state file for the very basic resource I showed you looks like. I don't think I need to read it for you. And you should be able just to match those two curly brackets. If you want to remove this resource, you should be able to edit the ID if you do some modifications outside your Terraform, that you should of course never do, but with the development version you should. And there is also an option to import your existing infrastructure into Terraform. As I told you at the beginning, you have an empty state file. If your infrastructure already exists and you don't want to, or you are unable to destroy it and create it with Terraform from the scratch, you can always use Terraform import feature. But what I want to warn you, you can import almost everything, every resource that is implemented in Terraform, except the basic one that is called compute instance. But the good news is, recently they merged some change from some upstream library that is used in OpenStack that enables them to implement it. So someone is already working on that feature. If you import anything inside your state file, beware of Terraform destroy, that I will explain in the next slide. Terraform destroy could destroy resources that you don't want to destroy, because if you import them, in our case, those are these resources we are unable to create programmatically. In our cloud, there are some networks that are already predefined by the administrator where our instances belong. And if we delete those networks, then the administrator would have to recreate it again. And if we destroy them, it might have some bad impacts on some other users of the same cloud. Fortunately, there is this erroneous behavior. If we delete something we don't have permissions to, it gets back from API that it's deleted, but actually it's not. So if we delete it, it's deleted from the state file, and it's not deleted from the infrastructure itself. Terraform Destroy is the last feature I want to mention today. If you want to, for some reason, if you want to destroy all the infrastructure you created, you just call Terraform Destroy. It calls all the APIs to destroy everything it created before. This is very useful when you work on some development. You come to the work at the morning and you pay for your instances or for your resources in some cloud. That's not our case because cloud is internal, so we don't pay for the resources. But you can work on it during the day, and at the end of the day you just call Terraform Destroy, destroys the infrastructure, and you don't get billed until next morning. What Terraform Destroy does is it clears the state file, and of course keeps your definition because it doesn't have access to your GitLab, it doesn't touch your files. And what are our best practices for using Terraform with our OpenStack cloud? You need to understand your infrastructure very well. Never use Terraform if you don't know what is it doing, how is it communicating with you don't need to know what API calls it needs to communicate with your OpenStack API, but you need to know it is creating this resource with those attributes, and this is the output. And what Terraform does for you, it means if you create a resource and you expect that something is going to be created, never expect, I don't want to make anti-advertisement for Terraform, but sometimes it happens that you create a resource with some features, and as I told, OpenStack API returns some unexpected return code. So the resource it declares it created might not really look like what you declared because, for example, you don't have permission to do this. What I already spoke about, decouple your infrastructure to very basic objects. So never, if you can decouple some components, do it like I told you we do with VMs and with ports. Share the state file wisely. There are plenty of different backends implemented in Terraform already. Some of them support locking, some of them don't. And there is a project on GitHub that makes some wrapper around Terraform that is dealing with the logs on some different way that's managed outside of Terraform. I never used it because what we do, we use it for CI/CD. So the only VM or only user that is using the Terraform state file is the GitLab runner that runs our CI/CD pipelines. What I want to encourage you to do is check your Terraform plan before applying, especially when upgrading from older version to new version. This is what happened with my recent upgrade from 0.9 to 0.1 to 0.6. That at the end of the pipeline there was a really huge red screen with plenty of errors saying it wants to destroy and to rename some resources because there was an incompatible change between those two versions. And that ends in my another I'm out of my English word, sorry. Another thing, always expect some trouble with Terraform, but to defend it, if you use it for things that you know what are doing for you, it's the best tool ever, because as many times as you run Terraform applied, as many times against the same state, at the end you have the same resulting environment. Of course, if you know what is it doing. I'm pretty sure, because the company is doing heavy development, when they release 1.0, it will be pretty stable, but it's not yet so bug-free. Expect yourself to write bug reports to developers, because this is what I do once or twice a month. And expect yourself to be compiling latest commits from GitHub using Go, because they don't offer any nightly builds. So if you want to use the latest Terraform, where if they fix your bug and they merge it to master, you either have to wait for the next release, or you have to compile your latest version yourself, because nobody does it for you. This is what took me a couple of hours until I was able to automate it. But what we do is we automate everything. So I wrote a pipeline that when we need to compile some specific commit, it does it for us. And then we, in our CI/CD environments, we just refer to another Docker image version which contains the new version. So after all, if you ask why shouldn't I use Heat and why I should use Terraform, I'm not so much experienced with Heat, but at the beginning when we were deciding which tool to use, we didn't like that if you create a stack with OpenStack Heat, you have to call different command than when you apply some changes to this stack. With Terraform, you just press arrow up and enter, and press arrow up and enter, then edit your definitions, press arrow up and enter, and at the end you have always the same resulting state. With Terraform, with Heat, we were unable to track problems to the very end point simply. So if something failed in OpenStack, we didn't have access to Heat logs, so we were unable to tell what was wrong with the creation. With Terraform and also with Ansible, what we achieved with all those tools we use, you just click play, everything goes all over again, and makes us sure that the infrastructure is at the state where we expected it. And if someone made any change out of our infrastructure definition, Terraform is the tool that always removes, or if you make a change to an instance outside of Terraform, it makes the change to match your code. That might be and might not be good, but for our team, where we are a couple of guys, if anyone makes any change outside of the CI/CD process, he should be punished, because every change should be committed into Git, and every change we do is logged, and we have all logs of applying of this change. Sorry? Yeah, I'm actually finished.
No, we are fine.
So if you have any questions,
yeah.
We have.
So the closing ceremony should start soon, but I guess for our final one or two questions, maybe we have time if they are quick ones.
Do you have the same? I have another tool back here, building images, and I have the experience with that. If something goes wrong with starting up a VM, you just say error instead of providing the correct OpenStack message like, hey, you choose on the wrong flavor. So do you have the same experience with
well, actually that's a message from OpenStack API, not from Heat, not from Terraform, not from anything else. So this is what I expected with, what I experienced with Terraform as well. If you put some bad flavor, the message from OpenStack is incorrect parameter or something like that.
No, the message is that incorrect flavor. So if you do that,
I have never seen a message from OpenStack saying incorrect flavor.
No, never I said incorrect flavor actually. Never. I'm using it. The message is in the logs that you don't.
Yeah.
Your this space is not enough for the flavor, but error in the console or in the API is error, not equals.
Well, I think what he's actually saying is that the OpenStack support in a lot of HashiCorp's products is less strong than their AWS stuff, right? It does the product an afterthought. Would you agree with that?
Sorry, really hard to understand you from me.
Oh, I'm sorry. So basically, the OpenStack support in HashiCorp's products feels of a second-class citizen compared to their AWS support. Would you agree with that?
That they support OpenStack the same as AWS? I wouldn't say.
Yeah, the question was if the level of support for OpenStack and HashiCorp products.
Well, I'm not experienced with they support on AWS side, but my experience with the OpenStack side is excellent. As I said, in the evening I go home. Before I go home, I run the bug report, and in the morning I got an email. It's either it's solved or they ask for some extra information. And most of bugs I reported are already fixed, and this is why I encourage all of you to use Terraform, because if you run into some bug and you know what are you doing, you can get a fix tomorrow.
Okay, thank you very much.